Hello, Coach Travis here with another calculus video. So this is a Newton's method problem, another Newton's method problem, and so the question is, we want to use Newton's method to approximate the square root of 74. And we want to apply Newton's method 2 times and round to the nearest hundredth, and we want to use the initial guess of 9. Right? So when you use Newton's method, you always start with an initial guess, and then Newton's method is an iterative process using this formula down here. Well, we'll talk about this, by which you can get a new approximation by using an old approximation put into some interesting formula that Newton discovered. So, all right, so how are we going to approach this problem? So, I mean, when you think about Newton's method, you should think about finding the x-intercepts of a function. That's what Newton's method does. Newton's method finds the zeros of a function, or equivalently, the x-intercepts of a function. And so I'm like, when I first read this problem, I'm like, well, where's the function? So you have to be a little bit creative here. You have to think, well, I'm trying to approximate the square root of 74. And what are my tools? What I can do is I can find x-intercepts. So I have to think about, well, what would be a function? What would be a function that would have the square root of 74 as an x-intercept? And if you think about it, for a little bit, you'll realize that, hey, yeah, if my function is x squared minus 74, then the square root of 74 is going to be an x-intercept of that function, because you can check if you put the square root of 74 in for x, you will get 0, and that corresponds to an x-intercept or a 0. So all right, so there's our function. That's the function that we want to apply Newton's method to. So Newton's method will allow us to find or approximate. Newton's method will allow us to approximate the x-intercepts of this function, and one of the x-intercepts of that function is the square root of 74. So all right, so if you think about Newton's method requires you to find the derivative. So I don't have the general Newton's method formula written down on the screen, but if you use Newton's method, this is the iterative formula that you get. That the next approximation is equal to the approximation that you have, subtract the approximation plugged into the original function, and then divided by the derivative of the original function with the approximation plugged in. So this is the original function, this is the derivative of the original function, and here's the Newton's method formula for finding an iterative sequence of better and better approximations. So all right, so this is what we have to do, and so as always, I like to use a spreadsheet to do this. So the problem says that my initial guess should be 9. So all right, so I'll type a 9 into that spot right there, and then into this next cell, I need to type this formula. And so whenever you're typing a formula in a spreadsheet, it starts with an equal sign, and now instead of typing x0, because the spreadsheet doesn't really know what x0 is, I'm going to type in the cell reference. So I'm going to say x0 is the number 9, and the number 9 lives in the cell B2. So everywhere I see an x0 in this formula, I'm going to type B2 into the spreadsheet. So the formula becomes B2 minus, and then let's see, so we're going to have B2 squared, and then minus 74, and then that gets divided by 2 times B B2. So that, if you look at that formula, that is exactly the same as this formula right here, only everywhere that there's an x0 in this formula, I have a B2 in this formula, and because B2 is referring to the value of x0. And again, I want to point out, make sure that you put a multiplication sign there, otherwise the spreadsheet will get confused because it'll think 2B2 is the name of something. And that's not what you want. And I'll press enter, and all right, and then it gives me my improved approximation. So obviously the square root of 74 is not 9, but the square root of 74 is pretty close to 8.6, or 8.61 is closer to the square root of 74. And now what you can do through the magic of spreadsheets is I can highlight these two cells, and I can click in the lower right corner and drag down. I can drag down as far as I want, and it'll repeat that procedure iteratively. And as you can see, it stabilizes pretty quickly. And you know, I'll highlight this one. This is the one that we want, because that's that it said it wanted, the problem said it wanted x2. So this is the one that we want. But the point is here, using a spreadsheet allows you to do iterative procedures like this really quickly, so you can get through your homework assignment really fast. If I was going to do this on a handheld calculator, I would have to be typing a whole bunch, and it would be really a hassle. But using the spreadsheet, I can just type this formula in once, and then when I click and drag, it'll retype the formula, but it'll update all the cell references. So like in this cell, we want to use the formula with the number that's in the cell B2. But this formula will want to use the Newton's method algorithm, but the input will be the number in the cell B3. And you can see that, oh yeah, the computer automatically changed the cell reference to B3. And down here, it automatically changed it to B4. So that was the magic of clicking and dragging. So spreadsheets are really smart about doing things like this. So they're a great tool. I highly recommend using spreadsheets when you're doing problems involving Newton's method.